Hello everyone, welcome to our weekly series of CBSE Class 10, and today we are going ahead with second part of the pair of linear equations in two variables. In part 1, we did the basics of linear equation in two variables, and in this part we'll carry on from here. The link to part 1 is already shared in the description. Make sure you watch that before you start with this part. Let's begin.
Now we move on to the concept that we are to study in grade 10, and that concept is pair of linear equation in two variables. So now these equations together represent the given information, and since together we have to study them to understand the conditions, therefore these are called pair of linear equation in two variables. If I only say x is equal to 9y, this is not going to help me identify the values of x and y. If I just give you x plus y is 50, again, there can be infinite values which will satisfy either of the equations. But if we want to find out that particular value of x and y, which is satisfied by both the equations, then we need to study both the equations together. And together they are called as pair of linear equations in two variables. Form of pair of linear equation in two variables is a1x plus b1y plus c1 is equal to 0. This becomes my first equation. a2x plus b2y plus c2 is equal to 0. This becomes my second equation. Here a1, b1, c1, a2, b2, c2. These are my real numbers, numeric coefficients, whatever you are able to understand. Again, the condition that both a1 and b1 together cannot be 0. Both a2 and b2 together cannot be 0. The same condition can also be written as a1 square plus b1 square should not be equal to 0, or a2 square plus b2 square should not be equal to 0. These conditions are necessary to understand because in some objective questions, they give the definition and ask the conditions as one of the options. I hope we have understood and we are ready to move further with the concept. Now, like how we had for a linear equation in two variable, a straight line graph, let us understand the graphical representation of the pair of linear equation in two variables. So, one linear equation in two variables will have one line graph. So, if there are two linear equations in same scenario, what we will get? We will get two straight lines. They are plotted together on the same graph. Let us see how. So, if there are two lines in a two-dimensional plane, then they can appear in three possible ways. The first way, the two lines may intersect at one point. We can have two lines on the graph which are intersecting at a point. In the second way, we can have the two lines which will not intersect at all. When is it possible? It is possible when the lines are parallel to each other. And the third possible way is where the two lines, they lie over each other. They coincide or they overlap. In the textbook, the word is coincide. So you can have one line and the other line also is exactly on top of the second line. So these are the three possible conditions which we can have if we have two lines on a two-dimensional plane. Now let us consider different scenarios where we may get such lines. So the first question is, the cost of 2 kgs of apples and 1 kg of grapes on a day was found to be rupees 150. A few days later, the cost of 1 kg of apples and 2 kg of grapes was found to be rupees 180. Find the cost of 1 kg of apples and 1 kg of grapes. Again, here we are having two unknown values. So let cost of 1 kg apples is rupees X and cost of 1 kg grapes is rupees Y. Let us see the conditions. Cost of 2 kg of apples and 1 kg of grapes on a day is rupees 150. So on day 1, since the cost of 1 kg apples is X, the cost of 2 kg of apples will be 2X, cost of 1 kg of grapes is Y, and the total cost is equal to 150. This becomes my first equation. Similarly, on the other day, we try to find out the equation. It says cost of 1 kg of apples and 2 kg of grapes was 180 rupees. So, the cost of 1 kg of apples is X, the cost of 2 kg of grapes will be 2Y, and together the cost is 180 rupees. So, algebraically, the given condition can be written as 2x plus y is equal to 150 and x plus 2y is equal to 180. Now we will see the same situation to be represented graphically. Now, first of all, we need to learn how to plot a graph for linear equations in two variables. Here, the two equations are 2x plus y is equal to 150 and x plus 2y is equal to 180. Let us find the method to find the solution for them both. My first equation is 2x plus y is 150. Now the best method to find different combinations of x and y that satisfy this equation is by writing one variable in terms of other. So here I have written y in terms of x, so y becomes 150 minus 2x. For a linear graph to be drawn, at least minimum 2 points are needed. So now how do we find it? We take different values of x and for that we find the corresponding value of y. Let us take x as 40. So that makes 150 minus 2 times 40 is equal to 150 minus 80, which is equal to 70. So the value of y for x is equal to 40 becomes 70. So this pair of 40 comma 70 is satisfying the given equation. Let us take one more. We will try for x is equal to 60. So y becomes 150 minus 2 times 60, 120. So 150 minus 120 is 30. So the another pair of x and y which satisfies the given equation is 60 comma 30. Now the next equation is x plus 2y is equal to 180. We will use the same method to find two values for x and y. First, I will write one variable in terms of the another variable. Now, we have to find the values of x and y. Here, I will take different values of y and find the corresponding value of x. So now let us take the value of y as 90. So the moment I take value of y as 90, I get x is equal to 180 minus 2 times 90, which is 180. 180 minus 180 is 0. So for y 90, the corresponding x is 0. Let us take another value for y. This time let y be 50. So x will become 180 minus 2 times 50. 2 times 50 is 100. So 180 minus 100 is 80. So the corresponding values of x and y which will satisfy this equation is 80 comma 50. You can also put these values in the equation to cross check your answer. So if I am substituting 80 and 50 in the left side of the equation, I get 80 plus 2 times 50. 80 plus 100, I get my right hand side value. Therefore, another pair of equation which satisfies this is 80 comma 50. Now let us try to put these values on the graph. Here we have a graph. On this, based on the values which are there for x and y in both the tables, we will plot the scale accordingly, and now we will try to plot the values. First, let us put for the first equation 60 comma 30 and 40 comma 70. These 2 points are, if I join these 2 points, I will get the graph for the equation 2x plus y is equal to 150. Now let us plot the points for the second equation 0, 90 and 80, 50. These are the 2 points which have been plotted. Now again, if I join them both, we will get a straight line graph for the equation x plus 2y is equal to 180. What kind of graph we are getting? We are getting two lines which are intersecting at a point. Now, what is the significance of the point where the lines are intersecting? So, the point where both the lines are intersecting, this point is actually lying on both the equations. That means this point is satisfying both equation x plus 2y is 180 and 2x plus y is 150. So this point where the two lines intersect becomes a common solution to the equations that we have framed. So we conclude here that when two lines intersect in a single point, the pair of equations in this case will have only one solution. The point of intersection will be the solution, and whenever the pair of linear equations in two variables give a solution, we say they are consistent pair of equations. For any kind of equations, if I am getting some kind of solution, such equations will be called as consistent pair of equations. I hope this is understood. Now we move further with another scenario trying to see if we can get other kind of graphs. Let us see the other case. Romila went to a stationery shop and purchased 2 pencils and 3 erasers for rupees 9. Her friend Sonali saw the new variety of pencils and erasers with Romila, and she also bought 4 pencils and 6 erasers of the same kind for rupees 18. Represent this situation algebraically and graphically and try to find cost of 1 pencil and 1 eraser. Again, let us see the algebraic interpretation of this particular question. Here we have to find the cost of one pencil and one eraser. So let cost of one pencil is rupees X. Let cost of one eraser is rupees Y. So for Romila, we see she purchased two pencils. Cost of one pencil is X. So cost of two pencils would be 2X. And three erasers would be 3Y. And together for two pencils and three erasers, the total cost she paid was rupees 9. Similarly, let us find the condition for Sonali. She purchased 4 pencils and 6 erasers for rupees 18. So we get the equation as 4x plus 6y is equal to 18. Now let us see the graphical representation of this. Again, I have 2x plus 3y is equal to 9 and 4x plus 6y is equal to 18. Now using the method we have discussed in the previous example, we will find two values for x and y satisfying both the equations. So for the first equation, we get the values of x, y as 0, 3 and 4.5, 0. And for the other equation, we get the solutions as 3, 1 and 1.5, 2. Let us plot the graph. Again, based on the information on the graph, I can see the values are in their tens. So accordingly, we have placed the scale. Now let us put the values one equation at a time. So first we will place 0, 3 and 4.5, 0. Let us plot. These are our two required points. Now if I join them, I get a straight line for 2x plus 3y is equal to 9. Now let us plot the values for the second equation. These are the 2 points plotted. These are representing 3, 1 and 1.5, 2. Now again, if I join them, I see brown colored line for the second equation, 4x plus 6y is equal to 8. What am I observing here? We can see in this case, both the lines are lying just on top of each other. So this is a case where all the points are common between both the lines. When all the points are common, we say that these two equations have infinite solutions. Since all the points are common, so all the points on one line will satisfy the second equation as well. So when two lines are overlapping, coincident, the pair of equations have infinite solutions. Here we say that the equations will have infinite solutions, and in the previous example I mentioned, if there is a solution, any kind of solution, we say that the pair of equations are consistent. But since we are not getting a unique solution, we call it as dependent pair of equations. So let me repeat, when you have two lines coinciding or overlapping each other for pair of linear equations in two variables, we say that both the equations have infinite solutions. Since it have solutions, it will be considered consistent, but because it is not giving me a unique solution, it is called as dependent pair of equations. I hope you are understanding what I am trying to explain. Now let us understand the third condition. Here they have said two rails are represented by equation x plus 2y minus 4 equals 0 and 2x plus 4y minus 12 equals 0. Represent the situation graphically. Here they are asking us to represent this scenario directly. So we will see the graph first. So x plus 2y minus 4 is equal to 0 can be written also as x plus 2y is equal to 4, and 2x plus 4y minus 12 is equal to 0 can also be written as 2x plus 4y is equal to 12. We get two corresponding solutions for both the equations. We will try to plot the graph. First, we will plot 0, 2 and 4, 0. When we join them, we get a straight line graph for equation x plus 2y is equal to 4. Similarly, let us plot for the second equation 2, 2 and 4, 1. On joining, we get the second equation 2x plus 4y is equal to 12. Now here what am I able to observe? That the two line graphs which we can see, they are parallel. A pair of parallel lines extended indefinitely will not meet at any point. And since it is not going to intersect anywhere, there are no points that are common between them. So in this case, we say no solution is possible. So if I am having two pair of lines which are parallel, then the pair of equation is said to have no solution. And since there is no solution, now these two pairs are no more consistent. We get inconsistent pair of equations. I hope this is understood. Now let us summarize the entire thing. So based on the graphical method of solution of pair of linear equations, we get when the lines intersect at a single point, we get unique solution and the pair of equations are called consistent. Please focus on the words which are colored. Similarly, if the lines are parallel, so they will have no point in common, and if there is no point in common, this is a case where no solution is possible, and no solution means inconsistent pair of equations. The third scenario was when the lines were coincident, overlapping, lying on top of each other. In such a case, all the points are common between the two lines. Therefore, how many solutions coincident lines can have? They can have infinite solutions. And therefore, it is consistent but dependent pair of equations. We just have to remember the colored words, and that is going to help us in the next set of questions. Now, if the coefficients a1, b1, c1, a2, b2, c2 of the pair of linear equations are compared, we observe a specific pattern which they follow for intersecting lines, parallel lines and coincident lines. So what do we observe? We observe that if the lines are intersecting, that is, two lines are there and they are intersecting. In that case, the coefficients a1 by a2 will never be equal to b1 by b2. And we can say otherwise also, that if two equations are given, if a1 by e2 is not equal to b1 by b2, in that case we will get intersecting pair of lines. Similarly, if two lines are parallel, in that case, what kind of relations we see? We see a1 by a2 will be same as b1 by b2, but this both will not be equal to c1 by c2. Very important conditions, and of the entire thing that we learned, this is the most important part that we need to remember. Similarly, if we are having two coincident lines, that means we are having exactly two same lines, but maybe their coefficients are different. Then what will be the relationship between the coefficients? The x and y coefficient and the constant terms, they are all going to be equal in case of two coincident lines. That is, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So, very important concept that you must learn before you start attempting your questions. Again, if the lines are intersecting, the condition would be a1 by a2 not equal to b1 by b2. If the lines are parallel, then a1 by a2 equals b1 by b2 and is not equal to c1 by c2. And if the lines are coincident, then all three of them are equal. I hope this much is very clearly understood. Now, based on this understanding, let us try a few questions. The first question here says, on comparing the ratios of a1, b1, c1, a2, b2, c2, find out whether the lines representing the following pairs of linear equations intersecting at a point are parallel or are coincident. Let us take the first example. 5x minus 4y plus 8 is equal to 0. 7x plus 6y minus 9 is equal to 0. Here, we will start by taking values of a1, b1, c1, a2, b2, c2. a1 is 5, b1 is minus 4, c1 is 8, a2 is 7, b2 is 6, c2 is minus 9. Now, one small reminder over here, before you start assigning the values of these coefficients, before that, make sure to write your pair of linear equations in their standard form. That is, the x term, the y term and the constant all written on the left side of the equation. Now, first we see a1 by a2 and b1 by b2. What is the relationship between them? Here, 5 by 7 and minus 4 by 6. Even when it is reduced, we see they are not equal. Since a1 by a2 is not equal to b1 by b2, the first pair of equations will give intersecting lines. I hope this is understood. Now let us take the other example. The equation is 9x plus 3y plus 12 is equal to 0. 18x plus 6y plus 24 is equal to 0. I'll first check, is it in the standard form? Yes, both the equations are written in the standard form. So now we find the values of A1, B1, C1, A2, B2, C2. Try solving it with me. A1 is 9, B1 is 3, C1 is 12, A2 is 18, B2 is 6, C2 is 24. A1 by A2 is 9 by 18, which is 1 by 2. B1 by B2 is 3 by 6, which is 1 by 2. C1 by C2 is 12 by 24, which is 1 by 2. What am I getting? I'm getting A1 by A2 equals B1 by B2 equals C1 by C2. This is possible when the lines are coincident. So on comparing the coefficients, we can say for these two lines, what kind of graph we will get? We will get coincident lines. I hope this is understood. Now let us try and see the other question. On comparing the ratios A1 by A2, B1 by B2 and C1 by C2, find out whether the lines representing the following pair of linear equations are consistent or inconsistent. Just a small recap, consistent is when any kind of solution is possible. That is, if A1 by A2 is not equal to B1 by B2, this is also consistent because here we get unique solution, and the condition A1 by A2 equals B1 by B2 equals C1 by C2. This is also consistent because here we get infinite solutions. So let us see the first example. Now directly if I take the values from the first equation, I get the value of A1 as 3 by 2, B1 is 5 by 3. Here both my constants are on the same side. So let us move them on the left side. So I will get C1 as minus 7, A2 will be 9, B2 will be minus 10, C2 is equal to minus 14. Now one very interesting or one very basic understanding here is A1 by A2 is going to be a positive value and B1 by B2 will be a negative value. So from here only automatically I can identify that the ratio A1 by A2 and B1 by B2 will not be equal. So if it's an objective question, just by looking at that, we can tell it will be consistent. But if it is subjective, we need to show the steps. So 3 by 2 divided by 9, which will become 3 upon 2 times 9. 3 3s are 9, it is 1 by 6. B1 by B2 will become 5 by 3 divided by minus 10, which will become 5 by 3 times minus 10. 5 ones are 5 twos are, which is minus 1 by 6. A1 by A2 is not equal to B1 by B2. Therefore, consistent pair of equations. If I want to be very specific, this is unique solution with pair of lines intersecting. Let us see the second one. A1 is 5, B1 is negative 3, C1 is negative 11. A2 is negative 10, B2 is 6 and C2 will be positive 22. Now again let us find the ratios. A1 by A2, 5 by negative 10. On reducing we get minus 1 by 2. B1 by B2 is minus 3 by 6 which becomes minus 1 by 2. C1 by C2 is minus 11 by 22 which further becomes minus 1 by 2. So we are getting A1 by A2 equals B1 by B2 equals C1 by C2. So again we know for this case also we get consistent pair of equations. This is a case where I get infinite solutions. What kind of graphs I'll get? I'll get overlapping or coincident lines. I hope this much is understood.
Thanks for watching part 2. The discussion of this chapter is divided in 5 parts. In part 1, we have already covered basics of linear equation in two variables. The link to this is already in the description. In part 2, we have completed the graphical and the algebraic interpretation of the pair of linear equation in two variables. Now using these concepts, we can easily solve exercise 3.1. In part 3, we will learn algebraic method to solve pair of linear equations in two variables, so stay tuned. Thanks for watching. Do like the content, share it with your friends of class 9 and 10, and ring the bell icon to get the updates at the earliest. Please comment for any suggestion or any specific chapter that you want me to cover after this. Enjoy learning.